Okay, now so let's do question 3. Form one round of gradient descent updates using the entire data set above and learning rate eta is equal to 0.01. So gradient descent, let's see really quickly. This is the formula, right? This is the way we updated theta as the parameters. The updated theta, the updated parameters are equal to the current parameters minus some kind of learning rate times the gradient of the loss function. So let's do all of this here. I like to write this here for when we need it. And so here, what's theta? What are the parameters? Theta is W and B, the weights and the bias. Yeah. And what's our loss function here? It's like we said above, let's call it L of theta, or if you will, LWB is equal, it's the MSE, right? So it's 1 over n summation I is equal 1 to n of h of xi minus yi squared, which is the same as 1 over n summation wt xi plus b minus yi squared, right? And I've written it this way so that it's easier to differentiate. You'll see in the correction probably it's written in another way, but let's do maybe both ways so that it's more beneficial, I guess. And so what do we want to do here? We want to, well, we have eta, right? Because they gave it to us. So now we want to find the gradient of the loss, right? So let's differentiate the loss with respect to each parameter. Let's start with W. And partial L partial W is equal to, so what do we do here? This is what we have to differentiate, right? We're going to use the chain rule. We're going to take this exponent, put it here, and then 2 minus 1 is going to be equal to 1. So the exponent is going to be equal to 1, minus 1, now write it, times f. So maybe a quick reminder, we should all have seen this by now, but this is, right, this is the chain rule. When you have a composite of two functions, the derivative is g prime f of x times f prime, right? Yes, I had it on my wall here, on my board. So that's great. So well, the derivative here is going to be 2n summation I over n, and then this is just f, right? F in the, I wish I didn't erase it, but whatever, times f prime. So what is f prime? If this is f, if we differentiate with respect to w, well, this is gone, and only thing that stays is xi, right? So xi comes here, and let's compute the same with respect to the other parameter b, and now we're still differentiating the same loss here, but with respect to b. So chain rule again, this is going to be 2n, 2 over n, summation I is equal to 1 from 1 to n. F, again, this is unchanged. And then f prime comes here. So what is f prime if this is f? What is f prime if you differentiate with respect to b? Well, this goes away, and this goes away, and this becomes 1. So we can write 1 here, or if you want, we don't write it. I kind of prefer without. So let's not write it. And let's move this a bit downstairs so we have more room for this guy. Okay, now we have to compute this. We have all the values, right? Um, Fortunately, we wrote everything here above, so I'm kind of just going to use this because I don't want to redo all the calculations. So first of all, n is 3, right? So let's write a 3 here. And then, okay, remember what we had for I is equal to 1? We had this guy, and then I equals to 2, we had this guy, and I equals to 3, we had this guy. Now we're not taking the squares anymore, and we're multiplying by xi, and the xi's are here conveniently. So we can write, so I'm going to take 1 for when I is equal to 1 for this, and then minus 5.5, and then minus 0.5, and multiply them by the xi's here. So, and feel free to do the computation again if you want, but I'm just saving some time here. 1, and then x1 is 1, 2. Let's take the transpose for simplicity for now. And then plus minus 5.5. And then what's x2? It's minus 2, 5. And then minus 0.5, right? Yes, here. Times 0, 1. Okay, hope this is right. This is equal to 2/3. Okay, let's just write a big vector now. 1 minus 5.5 times minus 2 is going to be plus 11. And then this is 0, right? So that's it. Oh, plus 0, if you will. And then below, it's going to be 2. And then minus 5.5 times 5, it's minus 27.5 minus 0.5. So that's equal to 2/3 times 12. And what is this? 20 minus 26. Can I write it somewhere? No, this is equal to 8. And below, what do we have? Minus 52 over 3. I guess this is right. Right? Yes. Okay, sick. And then now for this guy. Okay. Okay, I'll compress everything later. But now for this guy, well, it's the same thing, right? We already have everything from above. So it's 2 over 3. And we have all the individual terms. We don't have to multiply by any xi's here, so it's going to be much easier. It's 1 minus 5.5 minus 0.5. It's 2/3 times 1 minus 6. It's minus 5. It's going to be minus 10 over 3. Okay. What do I do here? Do I erase? No. Okay. I'm just going to put these here for now. Okay. And now, so now we have this guy. And we have this guy, and we have this guy, right? And we want to find this guy. This is what it means. This is what they mean by perform one round of gradient descent. This guy here, oops, this guy here is just the current parameters we have, W and B, which are, as you know, this is W and this is B. And so we want to update each of the W's and B's, right? And so let's do them one by one. I think you maybe can do it also. Yeah, probably you can do it together, but let's do it one by one. So let's call this new beta, new W. I don't know. Let's call this W2, whatever, new. So we're all computer science students here, so we can use this, but in a math class they would not be happy. W2 is equal to W minus nabla partial L partial W, right? And so this is going to be equal to, what is the current W? 0.5. I hope I don't mess up the dimensions here. 0.5 minus 0.01. And partial L partial W is this. What did we get again? This guy here. So, up. And then B is going to be equal to the old B. Same thing here. Partial L partial B. And the old B was 0 minus eta is 0.01. And the new B is 10/3. So can we compute this? Yes, of course, but I don't have a calculator. So I'm going to use my phone. So 1 minus 0.01 times 8, what do we get? 0.92. And then, actually I have the answer here. Okay, this is 0.6733. And then this guy is going to be 0.033 repeating, I guess. Okay, so those are, let's call them new. Let's be a bit rigorous. Or 2 or I, because the first iteration, whatever. So these guys are our guys. Perfect. So to sum up, this is the gradient descent formula. Those are our parameters, theta, W and B. This is our loss function. This is the differentiated loss function with respect to W and then with respect to B. And then we update each parameter here using this formula above here. And then we get these updated parameters. We performed one step of gradient descent, something we will do a lot in machine learning. Cool.